Welcome to math class online with Miss Heatherly. Okay, I wanted to do an example, and this I would put in your notes under dilations. This is a dilations example because I felt like we needed another example for you of finding the scale factor of a given dilation. So, putting this in your notes under dilations. So I give you the original figure, okay, in pink here, outlined in pink. And then the dilation that was performed, it got smaller. It went to the 1 to 2. So is it an enlargement or a reduction? Well, it got smaller, so this is a reduction. And now we need to know the scale factor. So remembering that if it's a reduction, the scale factor should be less than 1. So let's relate. Let's start by starting at the image. Scale factor, it's a ratio. It's the ratio of the image compared to the original. So let's go to the image. So if I go to the image, let's just say I picked 2. I'm going to write out the scale factor would be 2, ... and then I'm going to correspond that to the original. 2 corresponds to 8. Now, could I simplify this scale factor? Yes. It would simplify down to 1 to 4, or if I write that as a fraction, 1/4. So I'm thinking right now that my scale factor is 1/4. Well, to see if that actually concludes that it should be a reduction because 1/4 is less than 1. And now if I actually try it out, I should be able to take my original figure and take each side and multiply them by my scale factor of 1/4 and be able to get to my image. So let's see, if I take 8 and multiply it by 1/4, will I get 2? So 8 over 1, that's 8 over 4, and 8 divided by 4 is 2. Yes, it works. Okay, let's check it with a 4. 4 times 1/4. 4 over 1, 4 over 4 when I multiply, and 4 over 4 is 1. So my scale factor is indeed 1/4. Okay, I wanted to give one other example of that because we only did one in class. All right, moving on. The lesson today is on scale models. And so you will write this in your table of contents under the date today, which is the 9th, or maybe you're watching this on the 10th. So go ahead and write that in your table of contents. And we're going to start by what the heck is a scale model? So a scale model, it's just a model of something that is similar to the actual object it's representing. So we could have a scale model of a house. So it's really small, but the house that we live in, we can actually walk into. But I could build a house that's a scale to scale of my house to where I couldn't walk into it because it's so small. So I have my original house. Whoops. Okay. This is my house, and then I have a scale model of it, really small. But these two items, if it's a scale model, are going to be similar to one another. And what does similar mean? The sides are in proportion to each other, and the corresponding angles are congruent. So, let's start with a problem about the human heart. You actually went to the Science Museum in Chicago. A scale model of a human heart. A heart does not look like that. But a scale model of a human heart that is large enough for people to walk through. They can actually walk through the heart and see what kind of stuff goes on in an actual human heart. Isn't that cool? I want to go. If you want to actually see a picture of this human heart, the scale model of it. It's on page 192 of your book. But the height of the model at the Science Museum, the height of this heart is 16 feet. 16 feet high. This human heart that they built. The scale that they used, every foot is 9/32 of an inch. And the question is, what is the height of the actual heart on which this model was based on? So we're going from the really big one that we can walk through to an original size heart. We want to know the height of the original size that it was based on with this given scale. So the scale of a model is the ratio of the length of the model corresponding to the length of the actual object. So in this case, for every foot in the model, it represents 9/32 of an inch in the actual object. So I'm going to set up a proportion here to help me figure this out. So I know for every 1 foot on the model that the original heart is 9/32 of an inch. And then I'm going to set that equal to, it said the model at the Science Museum was 16 feet in height. So where is that 16 going to go, on the numerator or denominator? Well, it's the model, so it's going to go on this numerator because that corresponds with the numerator over here. These both deal with the model, the scale model. And we're trying to find what the actual height would be. So some of you might have figured this out without setting up the proportion. If I know 1 foot represents 9/32 of an inch in real life, then I'm going to take 1 and multiply it by 16 to get 16 feet. So I'm going to take 9/32 and multiply it by 16 to keep it in proportion. So 9/32 times 16. And instead of multiplying straight across, I can see that these reduce. Those both go into 16. That's going to be 1. That's going to be 2. So I'm at 9/2. And instead of saying, oh, the heart is 9/2 inches, well, that's improper. So I'm going to convert that to a mixed number. And 9 divided by 2 is 4 1/2. And is the human heart 4 1/2 feet? No, this was in inches. So it's inches. They based it on a heart that was 4 1/2 inches in height. All right, let's look at one other one. Let's look at scale model, but on a map. So you've probably seen this. You have a map, and it's drawn to scale, okay, so that we can fit it in a book or fit it on your computer screen. It's reduced down, right? It's reduction. And they give us the scale in this scale model. For every inch in the model, or on the map, it represents 75 miles in life, in the reality of it all, in the actual. And if I ask you, find the map distance from Columbus, Georgia, so there it is, Columbus, Georgia, to Birmingham, Alabama. To Birmingham, Alabama. So I want to know that actual distance to get from Columbus to Birmingham. To Birmingham. And if I say the way the crow flies, right? The way the crow flies. So the crow, or bird, instead of taking roads, they could just fly. Whoops, can I write on this? Yes. Come on, let me do it. There. You just go boom like that, right? Whereas us, we have to actually take roads and take the longer way. Let's say we're flying across, we're a bird. What's that distance? The actual distance. What are you going to have to do? Well, you're going to actually have to measure and figure out, okay, how many inches is it from here to here, which then I could convert into miles, because every inch is going to represent 75 miles. So we'll practice that in class and make sure you are good with your measuring tools. Okay? See you then.